Go Language Programming, Chapter 4, Unit 1. Pointers to a struct. We already have studied data structure using struct in Chapter 3. And we went over the employee data structure and used the dot operator to access the data field within the struct. In this unit, we are going to be using pointers to struct to access the fields within the struct. So struct fields can be accessed through a struct pointer. So once you create a pointer to a structure, then you can use that pointer to access a field within a structure. Now, in Go language, you can access the structure field two different ways. One is by using this notation right here, that is within the parentheses, you put a pointer type variable, and then outside the right parentheses with a dot operator and then the field name. That's the one way to do it. Go language also allows you to, so this is basically the first one, you're dereferencing and then you're dereferencing the pointer and you are accessing the field within the struct. The second way is just using normal way that you have used in C, C++, and also in chapter 3 that we saw how to access the field within the struct. You just use the pointer variable name and the dot operator to access the field. So basically that means you don't have to do the explicit dereferencing of the pointer like here we did it. So Go language does not support arrow operator that is supported in C and C++, this arrow operator. Okay, Go language does not support. So in C and C++, you also can do it the same way, the way that, the first way that we talked about with the pointer variable. But in C and C++, also provides the arrow operator to access the data fields within the struct. Now let's go over this example 4-1 and exactly see how this pointer variable is used to access the fields within the struct. So we have package main. That means our code will be compiled, okay, and it will generate a binary file. And within this code, we are using a FMT package. So we import that package so we can use a print line function to print out the variables, the data within the variables, and then we declare employee struct. So in Go language, when you declare an employee struct, you have to use this type keyword, and then after the name of the struct, which is the user-defined data type, you have a keyword struct, okay, just like a C or C++ name. And then the body starts with the left curly braces and then the right curly braces. Within the body, you can declare the fields for the struct. These are the fields, first name and the last name. And in this case, we are declaring both in the same line, and then we are giving the uh, uh, type of the field. And then next, we are declaring integer type fields. And again, they both are declared separated with the comma and then the type. Now, of course, you can declare each fields on its own line and give each of the field with the its type. Okay, that's another way to do it, which we already did it in chapter 3 when we were talking about the structures. Um, and we also went over other different way of creating the field names within the struct in chapter 3. Anyway, then we have a main function, which is an entry point function. The body of the function starts with a left curly braces and ends with the right curly braces. And within the body, I am creating an instance right here at line number 11, creating the instance of the for the employee struct. Okay. Now notice that I'm using n% in front of the structure name or the user defined data type name. Okay. And within the curly braces, I am initializing the data to the fields that that are within the body of the struct. Okay, so in this case, I am initializing Sam, and then is a first name, and Anderson, and then age and 6,000 salary. Okay, so basically, compiler will know which string and to initialize, because in this case we are not explicitly telling that Sam is going to be the first name and Anderson is going to be the last name. Compiler will figure it out, but we already have seen that how it is done. If you wanted to do the explicit initialization in chapter 3, we already went over. So if you want to, you should review that structures in chapter 3. Um, so once this data is initialized and the memory will be allocated for this type, employee type. So basically, in this case, since we are saying that this will be the address, which with the n% we are saying, so memory is allocated for employee right here. Okay, so this is employee memory, and in this memory all the data is here, and then this probably is located at some address 1000. And basically when we are creating this pointer, this will be the pointer, which will be the emp. We are putting this address 1000 right here, okay, by using a short initialization. So this will be pointing to here, okay, and so that way we can access the data within this memory, which was allocated when we created the piece of memory and initialized it with the data. Okay, now you can access this fields two different ways. One is with by doing the dereferencing, okay, by using the um, star, and then of course the dot operator to get the first field or the first name. So you are using the instance of the employee data structure, and using that instance by doing the dereferencing and accessing the field, the data from that field. Okay. Similarly, you can access the other field name, which is age. So that's the two different ways of doing it. Now you can also, like earlier I mentioned, that Go language allows you to just use the dot operator itself directly. You do not need to do the dereferencing. Okay, you can just do so. Even though this emp is a pointer type variable, this is a pointer type variable right here. This is a address. This variable is holding the address. Even though it is holding the address, Go compiler is smart enough to do the dereferencing itself. Okay, so we don't need to do the dereferencing. It will do as long as you use the dot operator to access the fields. So that's how the Go language basically will allow you to access individual fields. Now, let's go and see more different things in the structure. Okay, so now we're going to go over the anonymous struct fields. Now, what are the anonymous struct fields? Anonymous struct fields are those fields that only contain data type, okay, without the field name. So basically, you don't provide the field name, only the type within the structure, data structure, or the struct when you create your own or the user defined data type. Okay, so basically, you do not need to put any names in there for the fields. That is called anonymous struct fields. So by default, the name of anonymous field is the name of its type. So in Go language, if you don't provide the name of the field, then the type will become the name by default. Okay, and that's what it is called, the anonymous field. So we have example 4-2, and of course this example also has the package main. That means we will compile this code and generate a binary file so we can execute this program. And within this code, we are importing the FMT package so we can utilize the print line function from that package. And at line number 4, we are creating this struct called person, which is a user defined data type. Okay, and it has two fields. In this case, the field names are the same name as the type. Okay, so that's why they are anonymous. At line number 9, we have the main function, which is an entry point function for this code. Now, of course, this starts with the left curly braces and ends right here at line number 13. So within this main, the body of the main, it is creating an instance of type person. Now notice that in this case, this instance ad admin is just going to be not a pointer, because in the previous example we saw that we were taking the address of it. There is no address, so this memory for person will be allocated right here, in the memory, and admin, which is created, will be the name of this memory. Okay, so the label for this same memory, admin, will be there. And of course, this memory also could create it at some memory location, and it will have two fields. Okay, one is a type string, the other one is type int. Now, basically, right here within the when I'm creating the memory for a person, I'm also initializing the data for on that memory. So that's what the first one is a string type, and the other one is an integer type. So your this string will be used to put in the name or the data called John, and then 50 integer will be put in at the within this piece of memory as 50. Okay, and then we are just at line number 11, we are calling the print line function and saying that, okay, print this variable, whatever this variable is holding. So it is just going to print this right here, okay, the output. And then we are calling this anonymous fields function. So now let's look at the body of anonymous fields function. Within the anonymous fields function, what we have is we are creating admin, another um, instance of the person. Now, in this case, when we create this memory admin, as soon as we create it, you know, Go compiler has a capability of initializing these fields with, if it is a string type, then it will be empty, and if it's an integer type, it will be zero. So these two fields within this person struct, so we are creating admin of type person because the person is a user defined type. So now they both will be initialized to zero, okay, as soon as we create this line number 18. And then at line number 19, we are using a dot operator to access the field within the struct. So the first field is a string type. So we can just treat that because since this field is anonymous, so we can treat that just like a regular field and use the type as a field name. So that's why we are using admin dot string and then initializing the data. So the jack will go right here, okay, and then on the int we are accessing the int similarly with the dot operator, treating the int as a field name, and then initializing 50 right here, okay, and then we are using the print line function to basically dump the data on this data that we have it in this memory location. And of course, when we created this memory, the empty one, even it was created at some memory location, at 5,000. So basically, that's how you can access the anonymous fields. Okay. Now, in the next slides, let's look at the nested structs. What are the nested structs? Okay. So in other computer languages, it is called the composite, composition. So not composite, composition. So basically, that means you are creating a has-a relationship. Now let me kind of quickly give you the example related to the has-a relationship. What has-a relationship does is that, let's say you have created a structure called house, and then you also have a struct called furniture. So basically, if you create a field within the house structure of a type furniture, then you have the nested struct. So that means house. So you can read it out loud and make sure that your has a relationship is valid. Is that you can say house has a furniture. Okay, so that's the reason that you're saying house has a furniture is because house struck has a field name which is a member of the house, and that name is furniture. Okay, so that's the way how as a relationship works. So the structs are nested if one struct name is used within the other. So the example that I was just giving it to you, you know, the house is using the field name furniture within its body. So that's why they are nested. Okay, and nested is always really considered as a has a relationship, and it is called a composition, okay, in the programming languages. So one struct contains a field which in turns is other struct, okay, and that's what we just went over in the example of house and the furniture. So in the main, let's exactly see how all these things these applies within using within the code. So example number 4-3 will tell us. So we have a package main for example number 3, and then we import the FMD package, and within the this piece of code, very first thing we do is to create a user defined type address. Okay, so the address is a user defined type, and in this type we have two fields, city and state. Okay, so they are both are of type string, and of course they are separated with a comma. So these two fields will be within this address struct, and then we create at line numbers starting with line number 7. We have a struct called person. Okay, that is a user defined data type, and in this the body for the person we have three fields. Okay, two fields are using the built-in data types. You know, the name is using a string, and age is using a your int type, and then we have another third field which is called address, and it is actually of type user-defined data type, which starts with the capital A address. Okay, so that's how this address type is. It's a using this struct that we already created address, and that is called the nested struct. Okay? So in this case, if you want to, so this is also has a relationship. So address has a person. You know, now it doesn't really read out the same way as house has a furniture. So so in some cases it may not the same way has a relationship will read out, but it is considered as a nested structs. And in the main function, which is an entry point function, we create a variable of type person. Okay, so we are creating a variable of type person. So when we create a variable of type person at line number 14, the memory will be allocated. Okay, so now person has what? The person has three fields. So two fields are of built-in data type, and then the third one is of user-defined type. This one. Okay, this is a user-defined type. So basically, in this case, the memory for user-defined type will be also allocated in the contiguous manner in close to where the memory for a person was allocated. But in as soon as that was done, everything was initialized. That's the beauty about the Go language. It will initialize this built-in data type according to what types of field they are. So in this case, this will be a string type, Okay, this will be an integer type, and of course this is a address type. So within the address type, so this is basically will be both of the fields. There are two fields in this structure. Okay, so that will be initialized as a strings. So that will happen at line number 14. Okay, and of course this piece of memory was probably created at some memory location, and once it is done, then we can use the instance of person or a variable of type person to access each field within the struct. Okay, so we use a dot operator to do that, and we are in at line number 15. We are saying that admin dot name equals to Jack, so it will initialize the Jack in here. Okay, and then we are saying at line number 16, we are saying age. So admin dot age will initialize 50 here. Okay, so these two fields will be initialized directly. And then at line number 17, we are saying that we want to initialize the field which is a nested field within the person struct. So we are using this notation. We are same notation with the instance of the person struct or user defined data type person. We are using the admin to access the nested structure within the person, and we are saying that okay, we want to initialize this. So now what it will do, it will go into the that struct which is right here, and it will initialize the memory, which is in this case what we are saying that city. Now notice that in this case we are giving explicitly, we are telling that okay, we have the name for the field, for both of the fields. So those names are city and state. Right after those names, we are putting the colon, and we are saying that the data will be initialized to each one of them. So Chicago and Illinois. Okay, so that's how you do it. But notice that we have a curly braces. That means these two fields must be within the body of this actual structure for address. Okay, so that's how it will be initialized. And then we have at line number 22, we have we are saying that we want to display the name field from the person struct. So we just using the name dot, I mean admin dot name and admin dot age. So they both will be printed right here. Okay, and then to access the the fields from the address struct, we have to use the instance of type person and get the nested structure name, that is address, okay, within the person, and then use a dot operator on the field name for the address. So that's like we have to use the dot operator two times here. Okay, so that's how you can print out the Chicago and Illinois. Okay, so basically nested structures will allow you to either initialize the fields or read the fields of the inner structure. Okay, so now in the next slide, we will go over how the promoted struct fields works. Okay, so we just went over the anonymous struct fields. So anonymous struct fields in a struct are called promoted struct fields. Okay, so basically, um, in anonymous struct field that we went over, we did not have the names next to it. So, but they are also called the promoted fields. So they can be accessed as if they belong to the structure which holds the anonymous field. Okay, so they basically are done in such a way that it becomes a part of that structure. Okay, so in this example, we have in the code we have a main package. Okay, package main, for example, 4-4, and then we are importing the FMT package, and then we are creating at line number 4, we are creating a address structure, user defined type struct, which has two fields in there, city and state of type string, and then we have a person struct. Okay, and within the person struct we have two fields which are basically its own fields, name and age, and then we have anonymous struct in there. Okay, which is called the promoted field. Okay, so basically, let's see how we can access this promoted fields from within the main. So in the main, like in the previous example, very first thing we do is to create an admin instance of type person. Okay, so that means we allocated the memory for admin. Okay, and as soon as we allocated the memory for admin of type person, that means we got these fields within this memory, so including this anonymous or the promoted field. So, but these all are initialized to 0, or if they are string type, then they are empty. Okay, and then we are using the admin.name to access the field, so we can write the data at that location. So right here we will be writing John, and John, and then at age we will be writing this 50. Okay, and then at line number 17 we are using the promoted field. Okay, and initializing just like the way that we did it before. So initialize the anonymous struct field. So we are, accessing the actual fields from the anonymous struct field, which is in a separate struct or separate user-defined type, which is called the address, and initializing the data to it. Okay, state and for city and state. And then we are at line number 21. We are basically reading whatever we initialize by using the instance, which is admin.name and admin.age and admin.city. Okay, all of these are coming from the person um, uh, um, field. Um, and basically, so the difference in between last example and this example is that here you are using the admin instance to access the city uh, uh, and state from the address. In the previous example, for the anonymous field, you had to use a two dot or two times the dot operator. Okay, so that's the difference. So if you use the promoted fields, okay. So basically, when when the printf will or the print line will do the printing, this is the what you will see it on the screen. Now let's go over how struct equality works. Okay, so struct equality is basically that means two struct variables are considered equal. Okay, if the corresponding fields are equal. So that means you have created a two instances of the same data structure, meaning same user defined data type, and now the only difference is that the data that they hold, the each instance, if they are same, then they are considered they both are equal. Okay, if the data is different in each instance, then they are considered that they are not equal. So let's look at in more detail in this example. So struct variables are not comparable if they contain fields which do not which are not comparable. So each instance has a different data, so they are not comparable, then they are not equal. If struct contains map, now that's a key point to remember. If struct contains map type field, so that means you have a structure with a field with a field that is created with a map type, the two variable struct cannot be comparable even though they have this exact same data. Okay, so there is no way that you can compare. The compiler will generate an error. So in this example, let's look at how the struct equality works. Okay, so in here we have the package main example 4-5, and it is importing the FMT package. And now we are creating a struct that has a the user defined type name is name. Okay, and it has the first name and then the last name, two fields in there. They both are of type string right here. Okay, and then our main entry point function starts from line 9, and within the main struct we create a two instances, admin 1 and admin 2, by using a short notation, dot colon equals to notation. And basically what we are doing is to allocating the memory right here of type name. Okay, so this means we have this memory right here, admin 1 and admin admin 2. Okay, so they both are within the memory. Once the memory was created right here, they initialized to empty strings. Okay, but since we are also giving the data during the time of the creation, the Steve Jobs will be initialized right here, and then Steve Jobs will be initialized to this one as well. So they both are at different address location. Okay, so basically these both memories are created at different address location. And then since we already initialized, so both memory location has some data. Okay, and they are exactly same data. And then if we at line number 12, we are using an equality operator to compare two instances. So in this case, since we both have the same data, so this statement, if admin 1 equals to admin 2, which is going to be true, so it's going to come right here and it will say they are equal. Okay, so that's what the struct equality means. As long as the data is same, then it will basically say it is true. Now, in the rest of the part of the code, starting at line number 18, I create another instance. So another instance, for example, right here, admin 3 is created. Okay, when admin 3 is created, we are explicitly giving the field names to initialize this data. Okay, field name and then the data. So, that will be initialized. So, as we talked previously, whenever you do that, you have to use the colon after the field name and then give the data. Okay, you use a colon and after that you give a data. So now the instance was created and the first name, okay, and the last name were initialized to this, and then we create another instance. Now in this case, as you can see, the curly braces are empty, so instance admin 4, okay, is created at, let's say, some address location 5000, and this is at 6000. And in this case, here the data was initialized, the Steve and jobs. Okay, here the data will be empty. Okay, so these strings will be empty uh, because of this empty curly braces. So we notice again we are using a short declaration operator. Okay, colon equals to. Now after initializing admin 4, at line number 20, we are using admin 4 dot first name. So then we are saying, okay, go to this field name, first name from the name struct and initialize that to Steve. So we are saying Steve. See, okay. So now it is initialized. But at line number 21, we are comparing it. Okay. Now we are comparing it. So admin 3 is compared by using a equality operator with admin 4. Okay, so when we say equals to, it is not going to be equals to. So this statement is false. So it is going to come to the else part, and it will print out this not equals to. Okay, so that's how this equality basically works in Go language. I mean the struct equality. Okay. So now let's look at what happens in the next slide. Let's look at it. What happens with the map if the map is used as a field within the struct, okay, which we discussed. So struct cannot be compatible if map data is used. So you just cannot compare two instances of a struct, even the data is exactly the same. Okay, compiler will generate an error. So in this example, 4-6, we're using a package main, so we can compile this piece of code and execute. So in here, in this code, we are importing FMT package, so we can utilize the print line function. And at line number 4, we are creating a struct called image. Okay. Now within that struct, there is only one field, which is the field name is data and it's of type map. Okay, so that's the way that we are using the map. We are using a map within in the struct as a field. And in the main, which starts at line number 9, we are basically creating the body for entry point function, and the body ends at line number 23. So within the body, we are using a short initialization right here, okay, and creating the variable image 1, okay. And then we are saying that in that image, what we want to do is use or utilize this map field from the image struct or image user defined data type, and initialize it to this data 0 and 155. Okay, so that's how it is going to initialize this map. And once that is done, we have the another image. Okay, so we have basically two memories created, which is image 1 and image 2. Okay, and in both piece of memory, I have this one field in there, and that field is initialized with the exact same data. But this field is of type map, both as the field name type map. And now, once we do that, we come and do the printing, So we do the printing, and in this case, basically, it says invalid operator. Uh, um, well, this is going to say it at the time when it is trying to print this, So what at line number 20, we are using image 1 and image 2 and trying to compare these both piece of memory, but unfortunately that would not work because you cannot have the map within the struct and create an instance of the struct and trying to compare it. So this equality operator would not let you do that. Okay, but in general, you should be able to have the map within the struct. It's not that you can't use a map within the struct. It's just you cannot create two instances of the struct and trying to compare it. So that would not work. Okay, but the map in general is allowed to use as a field name within the struct. So that basically concludes this uh, uh, chapter 4, unit 1, and let's go over unit 2. Okay.